Hi everyone, my name is Scott Tomlinson. I'm a senior traction power engineer with PGH Long Engineering, and we do design work for Valley Metro.
Hello, my name is Bernie Rosario. I'm a signal engineer for PGH Long Engineering, working for Valley Metro.
We both want to extend a warm welcome to all of you participating in Engineers of the Future. We're really very happy to have you guys because engineering needs more diversity, more opinions, and just generally more people to help with the projects that need to be done around the country.
We're going to be your mentors for the next few weeks, and throughout a series of pre-recorded videos, we'll be sharing some awesome facts about engineering and STEM learning.
Yes, and we're also going to be showing you some step-by-step processes, building very cool, well, we think it's cool, and a very tough truss bridge, and some other things that you may need in order to build the bridge.
We want to start off today's lesson by telling you a little bit about Engineers of the Future and the importance of STEM learning.
Engineers of the Future is a free program for students like yourselves and schools throughout the Valley Metro Workforce Development Program. Engineers from PGH Long, Valley Metro, and several other consultants will be acting as your mentors and helping to teach you about STEM and helping you to build some interesting projects.
This program provides opportunities, training, and mentorship to grow next generation of engineers in our communities. We want you to come and join us.
So now it's time to build a bridge, specifically a truss bridge. A truss bridge is exactly that. It's a bridge made of trusses. Trusses are very rigid. Trusses are also very light, so they have some advantages. Trusses are most frequently made of triangular sections because triangles are inherently more stable than other sections, and we may discuss that in a little bit more detail. As you can see, this bridge is made of popsicle sticks and wood glue. Nothing more, nothing less. You're not going to be allowed to use clips, drills, pegs, anything else, just glue and popsicle sticks. This is half of the truss bridge that we built in advance so that we can show you how to build a truss and then combine the two trusses into a bridge. And then at another time, we will show how we're going to destroy the bridges and measure how much force they can actually deal with. In order to build the bridge, we've discovered that it's necessary at some point to have both sides of the bridge held together, just to allow the glue to cure. In order to do that, the concept was to use a bar clamp so that you could stand two pieces up and then clamp them together. But bar clamps are expensive, and yes, engineers were cheap. So I started looking for inexpensive options for bar clamps, and even the least expensive one was too much for us cheapos. So I was thinking about it, and I thought, why don't we have the kids make their own clamp? So we got some bamboo pieces, and I cut the pieces together and tested the theory, and in a short afternoon, I built several clamps. Now, you're going to probably need two clamps to build the bridge. We're going to supply you with one that we know works. And then you're going to have to build the other out of parts. And we'll demonstrate that for you too in a follow-up video. But it's all very basic, and part of this is to learn how to innovate. Sometimes, well, in years gone by, woodworkers always built their own tools. They needed something, they built it. It was almost all special built until companies like Stanley and Black & Decker came along, and then they started making things for the common people. Otherwise, you made the tools that you needed. And that's one of the things we're going to teach you how to do.